Okay, welcome back, everybody. I hope you enjoyed your coffee. We will continue with the next session, which are people that are project partners, but not necessarily a work package lead. The person announced first was Peter Kwatzheim. Unluckily, he is at sea and we couldn't arrange a connection over there. So we found Lars Odegaard happy to take his place. So Lars, welcome. Good morning.
Thank you.
And the floor is yours. Yes.
Yeah. Yeah, there you can see the presentation, yes. Yeah, Peter is on a sea trial. He's trying to measure how well the whales can hear at different frequencies. And this is important to understand the consequences of the ambient noise maps made by JOMOPANS. So he's doing a very important job, but he couldn't be here. So I will give this presentation on FFI's contribution to the JOMOPANS project on ambient noise in the North Sea. Also, FFI has been working with underwater acoustics and ambient noise for more than 50 years. But also our main customer is the Norwegian Navy. But especially Petter has had several projects on how, for example, the sonars on our frigates are disturbing whales and such things. So we have been working in the field as JOMOPANS is working on for many years as well. Yeah, there it is. So the Norwegian contributions on JOMOPANS is so it's 2 measurement stations, but also one is in the North Sea and one is the Love. Love is for Lofoten Vesterålen, and that is a reference hydrophone, and it's interesting for the JOMOPANS project because it's from a very quiet area. And yes, so here is an example of the data from the Love hydrophone, and as you see on the spectrograms below there, it's easy to see the effect of weather, of the wind on the high frequencies, while the and you can also see single ship there. So the thought behind using this station was that then you could test the model on single ship passages and to test the model on wind. And therefore, this was part of the first part of JOMOPANS. So, for example, the results from the April 2018 was collected. It was collected by the Institute of Marine Research and processed by us at FFI. So, and the spectrogram you see below there is for a complete month. Yes. The hydrophone used in the JOMOPANS project is in the North Sea, and it's in the Norwegian trench of the North Sea. You can see the arrow in the image together with the AES information, so you can see that the hydrophone is close to the main shipping line along the Norwegian coast, and the depth is 300 meters, so it's the deepest site in the North Sea. It's much deeper than all the other sites in the North Sea in the JOMOPANS project. So the hydrophone we used, it was a simple loggerhead hydrophone, but it worked very well. So we deployed it in January 2019, and it was out for and recovered data to December 2019. When we collected it with the FFEI's research vessel, HU Sverdrup. Yeah, so then so this hydrophone FFE has just done the measurements and the processing and delivered the data from this data. So, and it's, as I mentioned, a loggerhead. Also, it's a cheap and simple hydrophone, but it worked without problems for a whole year. So that's was very good. And here's an example from the data from this Norwegian trench hydrophone. And as I mentioned, it is close to the main shipping line. So you can see much shipping noise there all the time. And then shipping noise is between 20 and 500 hertz. While over 1000 hertz is the wind that is dominating the spectrum, as you see in the picture. So yes. Any questions?
Okay, thank you very much, Lars. Are there any questions on the chat?
There's one question. Lars, do you remember, was your autonomous hydrophone loggerhead DSG-ST? Your autonomous hydrophone? Yeah.
Yes.
Was it loggerhead DSG-ST?
Sorry, I don't remember exact the number.
All right, that makes sense. Yeah.
Okay, are there any more questions?
Not to Lars at this moment, no.
I had one, Lars, at the very end you showed this pattern from the trench about what frequency ranges were dominated by the shipping and what by the wind. There was some fluctuation. Is there? Can you say anything about diurnal patterns with respect to both wind and shipping? So is it more nocturnal or diurnal? The activity from shipping.
I'm not sure I understood the question.
Well, you see the spectral dominance around 20 to 500 hertz for the shipping and above 1000 for the wind. And you showed a pattern of multiple days. And there were some breaks in there and maybe even a rhythm. Has that to do with the cycle of the day? Like, is shipping more nocturnal or diurnal?
Okay. I haven't really studied whether it's any pattern over the day. But as you can see single ships in the map. I can't point on the picture, but yeah, I haven't really studied the pattern, whether it's more shipping in the morning or evening or such things. But you can clearly see the weather systems, for example, on the example with wind I pointed on.
Okay, thank you very much, Lars. There's here another question from the chat.
Yeah, there's 2 questions on the chat. Maybe you can choose which one you like to answer or both. The first one from Bas, is it an advantage or disadvantage to have such a deep location? And the second from Jochem, I think Bas' question is answered by Rosalind. So from Jochem, could this data be compared to other hydrophones? Maybe it's quite difficult since the depth is so unique.
So the results are usually not very different whether you measure it deep or shallow. Also, that's my experience from other measurements we have done at FFI. It's some differences, but not many dB. So I think it can be compared. And also one good thing with having a deep site like here is that you don't have the trouble with trawlers.
Yeah,
so
makes sense.
Yeah.
And it can be a big advantage. Okay, thank you very much, Lars.
Thanks, Lars.
We go from Norway to Belgium to the next presenter. Next presenter is Alain Norro from the Royal Belgian Institute of Natural Sciences, Brussels in Belgium. And Alain, the floor is yours.
Okay, can you all hear me?
Yes.
Oh, okay, good. So I will be talking for 10 minutes about what we did for measurements in Belgium, and mainly that's the station that we made available and working at the Westinde. So what the station look like? It is one monopile that is there from already few years. That's belong to a network of the Flemish government of Belgium, and we were kindly accepted on board to include our station, which is quite nice because one of the main problem in Belgian water is the fact that you are operating in a zone where there is a lot of trawling and things like that, and any kind of instrument that you leave on the seafloor for a long time get a high chance to be trolled away. So what's the station look like? The station is constituted of hydrophones, Bruel & Kjaer 8104, including an amplifier, which is RTC's made, which is located close by the hydrophone. There is one recorder, and there is a further valise with some electronic equipment, including the hard drive that are used to store the data, and also an output of selected data that are computed into that valise, and that is reaching the shore using VHF. So the installation of the permanent station has been made using scientific diving techniques to put the hydrophone at the correct place and to check them further on when when we did clean it them for avoiding some underwater sound problem due to the covering of the hydrophone by marine life, of course. The station has been installed on the monopile, is powered by the monopile itself. And as I told you, few data like the 95 percentile of third octave level at 63 Hz and 125 Hz and 1 kilohertz are sent to the shore every minute, together with the size of the hard drive. Then you know more or less how the data gathering is about. Of course, there was an important work made on calibration. Jens told you a few words about that. Stefan also. That is quite important that we verify that the calibration of the instrument are quite okay. And with the kind of double calibration we are doing, we are calibrating measurements of less than half a dB. So the Westender station is the further south of the JOMOPAN. You are used to that map. Huh? So it is the one. I don't know if you see my mouse, but it is the one here. What is sent to the coast is a text file every minute with the data that I explained already to you, and all the raw data that are accurate at 72 kilohertz are stored on a 4 terabyte hard drive that are located into that valleys. Of course, when you put something like that at sea, you soon or later find out some problems and some difficulties. So here we have been facing few technical problem, first with the valise itself that wasn't working as expected at the beginning, that need to be disinstalled and sent back to the factory, sent again, and so on and so forth. And also later on during the COVID closure, we have been trolled away, or hydrophone has been taken by, I guess, by a troll or something like that, and that resulted on damage of all the cables that were going at that moment from the outside of the monopile attached to a staircase and going into the water. And now we changed that, and now we route the cable by inside the monopile. We have a chance that this monopile got some opening underwater, and we could manage to route the cable by the inside. And now, after a full winter, there is no more problems with cables, and we have not, we didn't experience any trolling because the hydrophone are quite close to the monopile, as one is shown here. This is the view of the inside of the monopile. So the one key message also with the 2 minutes that I still have is to highlight the fact that when you are under development of such a system, you have to take care of having a backup solution, like a backup hydrophone that is nearby and that can be used to be sure that you end up with some data. And you can also cross check what you measure with the results of the backup data. Now the system is more stable, and within the next year, with the help of the extension, we could work on a more secure way in terms of data gathering, and also we will be looking at, Jens already told you, at some aspect of data quality, especially in regard to tidal current, because so far there is a possibility that you remove the measured data that are showing that we're taking when you have a high current due to the tide, which is something that you can forecast by modeling very easily. And there is also another possibility on the data treatment, of course. And so you have to keep in mind that it's not because it's an online system holded on a big monopile like that you can access your data easily. It is far away, it is offshore, and there is a lot of limitation to be able to reach your instrument. So I would like to finish by some acknowledgement. The first, the acknowledgement of the marine life by itself, by marine mammals that were very nearby the spot, and also to our colleague Johan Verkruis and Bruce Benoot that helped me quite a lot on permitting us to put the instrument in their monopile. Officers and crews of the two research vessels that we use to reach to the site, and the scientific diving team of RBINS and some colleagues for some photos. So I would like to complete my presentation here. I'm ready for questions.
Okay, thank you very much, Alain, for this view into the work in Belgian waters. I look at Barry for some questions from the chat.
Not at the moment.
Not at the moment. Yeah, I had a question because the recorder is at a monopile, Alain, and obviously many people know that the monopile is not on its own over there. Do you foresee that you also recorded a lot of pile driving activity or sound from operational wind farms, or does it have an impact on vessel activity?
That monopile is situated mainly at the center of our zone, while all the wind farms are on the border with the Netherlands, which is on the other side of the Belgian coast. So yes, for sure, we could hear some distant piling because we are at more or less 30-40 kilometers from the wind energy zone, and also. Of course, we are on a situation nearby a very heavy used shipping lane, and it's difficult to discriminate operational sound from wind farm that is far away from shipping sound that is nearby, and all that result on quite a high level of underwater sound for the ambient sound. I hope this replies your question.
Yes, that's very clear. Thank you very much, Alain. No more questions? Okay, thanks, Alain. We'll move on to the final speaker of this session, and that is Karen de Jong. And I'm happy to introduce her because for one reason, she was one of the very first students of mine at Leiden University, and I published my first underwater acoustics paper together with her. So I'm still dedicated to her. And Karen is now working at the Institute of Marine Research in Bergen, Norway, and you will address biological aspects, Karen. The floor is yours.
Thanks, Hans. So with the team from IMR in Norway, we prepared a short video about our involvement in JOMOPANS and what we learned from it, and I'll be available for questions afterwards. You can start the video.
I work here at the Institute of Marine Research in the nice city of Bergen, as you see here, sunny as always. I work on how sound in the ocean is affecting marine life, mostly fish, and I work a lot with seismic and how seismic is affecting fish, but also other sounds like boat noise.
Hi, I'm Karen de Jong. I work at the Institute of Marine Research on the effects of noises on marine life, and my focus is on fish communication and reproduction. So Lisa, why did you think JOMOPANS was interesting?
Well, I think JOMOPANS was very interesting because it's a lot of countries, all the countries around the North Sea coming together and trying to do something in common. And it was a really nice network of people that I really wanted to get to know.
So I found JOMOPANS very interesting because it combines all the countries around the North Sea. So it looks at the impact from a more general level. And also I'm really interested in boat noise because it's a continuous source of noise, which is very important for animal communication and master. Yeah, so what we see here is the database of IMR, where you can actually see the spawning areas of cod, and the small ones are herring in the North Sea. And this is actually one of the things we've contributed to JOMOPANS, so that in the tool we'll be able to overlap the areas of where the fish actually are and behave with the noise maps of JOMOPANS.
So just with your eye, can you see whether they're actually spawning in the most noisy area there?
So the cod area is definitely also in the very noisy areas of the North Sea. Yes. So the main thing I think I've learned from JOMOPANS is that I got a lot more insight into the European structures that govern noise monitoring and noise mitigation. And yeah, this was very interesting for, of course, future work in Norway on effects of noise on animals and how to monitor this in Norwegian seas.
Hello there, Gusung. Can you tell me what you're doing?
Yeah, hello Lisa. I'm working on the VMS data. So I'm taking the VMS data from the IMR's server and then pick up them for the JOMOPANS project. Yeah.
Yeah, so what is it that we see on your screen here?
The screen here is all the fishing boats within the mountains outside the Vestland, in the northern part of Norway, Vestland, or Lofoten, Vestland. So this visualization shows you all the fishing boats on the sea. Yeah.
Yeah, okay. And this will go into the model in JOMOPANS.
I think so, because we are going to represent and show you. So we are going to represent the boat's information, and that will be used by the modelers, I would say.
Oh, so it's quite a lot of data you get.
Yes, a lot of data. So we got the fishing boats position our one position each hour, and we give this information to the JOMOPANS project, including the ship's position, time, also the lands. So we will, and sometimes the motor information. We will help the JOMOPANS project to model the ship noise in the sea.
So Lisa, what do you think is the most important contribution of JOMOPANS to future Norwegian management of noise?
I think one very important thing is that we have learned a lot about sound modeling and how to do that, and that's something that we're gonna take with us into some new projects that we have here at IMR, where we try to put together all different sort of anthropogenic stressors to the marine environment, including noise, and putting that together to see how different ecosystems are affected by anthropogenic activities. And we're going to use especially traffic noise from shipping and do it the same way as we've done in JOMOPANS to model noise and see where areas are very affected by noise.
Okay, thank you very much, Karen, for showing this video, sharing the scenery at Norway and giving us nice insights with a different perspective. So you're now happy to answer questions, I guess, or did you want to add something? Cool. Then I look at Barry for questions from the chat.
Yeah, I think people really enjoyed your the video that you made, Karin, on the chat. So you get many compliments on the chat about that video. I have to be honest, we have been mainly discussing the weather in Bergen because it was such a sunny day that you shoot the video. So there were a lot of comments on the chat about the weather. No questions at this moment. I think your professor should have a question.
I have a question for you. I was very interested, obviously, in the match that you suggest we could make with the sound maps generated by measurements and modeling within JOMOPANS with maps for animal distributions, the fish spawning sites. As I believe for fish, they are very much determined by historical spawning locations where they will go and spawn again, and maybe more so than by the current conditions. What kind of analysis do you foresee would be very interesting in the future with the JOMOPANS data?
So of course, if you in Norway, we have a procedure where we actually update these spawning maps every year based on yearly surveys and literature. So these kind of spawning maps could actually tell you historically whether there have been changes that could be related to increased boat noise, for example. Does that answer your question? Or?
Yeah, so that would be the exact locations of spawning areas. And so there are apparently shifts that we know, and even there's historical patterns that we could match actually with what we know about vessel activity. But I think, are there also data about, well, relative reproductive success rates among spawning areas? If there is a spawning area that is right on top of a shipping lane, can we compare that with, well, spawning areas that are in more quiet areas?
So that would be really interesting, but it is really hard to actually locate reproductive success. At IMR, there is an egg survey where they actually look at the eggs in the water column at different places within Norwegian waters. But it's always hard to actually model where these eggs exactly come from. So this would be a very interesting approach, but it would require quite a lot of effort to actually get these reproductive success for each spawning area.
Yeah, so that is likely due to all the currents and unpredictability of where eggs will go after they after the spawning. Yeah. Okay.
I have a question.
I'm looking at the time, but Niels here has a question for you.
Hello, Karen. Thank you for your beautiful video. We concentrate on the North Sea, but of course Norway has also a very large sea surrounding it, economic zone also within the Barents Sea, the Arctic region. Do you have specific plans for that region as well? in
Yes,
relation to
so,
underwater noise?
So currently we are developing how to actually assess these the effect of ships in those areas as well. And here we are planning to use the results from JOMOPANS to develop our methods for how to actually monitor these pressures in both the Barents Sea and the coastal waters of Norway.
Cool. Thank you very much, Karen. Well, we invite you to stay on the screen, on your spot, and we will invite also the other presenters of this morning. And if possible, we will see all 6 here. And that's because we will have a kind of an open session, and we will fire some questions to each of you when we get them from the chat. So it's an open discussion, and anybody can ask questions to any of the presenters of this morning. And I see Chris back, I see Jens back, and Karen remains. And we'll just see people turning up on the screen. And in the meantime, Barry, do we already have a question?
No, we did have one question left from the morning session. I think we will go more into this in the afternoon, but
Okay.
I can already ask the question. Maybe one of the speakers know the answer. So could you develop a species-specific filter that would give more insight into species-specific impacts? I don't know who wants to answer that question.
Species-specific filters. I see Chris.
Shall I try to answer that? Yeah.
Go ahead, Chris.
Yeah, species-specific filters. Well, on one hand, there's the location of the animals, and Karen already showed you that the maps of distribution of animals and the connection of that to the shipping. That's something that will be addressed in the GES tool. Species-specific filters also have to do with the frequency sensitivity of the animals. And each animal has its own range of frequencies which it hears best. We have discussed the possibility of including these filters for specific animals in the sound maps as well. But of course, then you need standardized filters, and they are not readily available. And you need to decide which species you're most interested in. We already made a clear choice to go for sound pressure and not for particle velocity. So we excluded some species on the start. And in the end, for the maps that we produced, we have made a distinction between low frequencies, mid frequencies, and high frequencies. So for the 3 ranges where various animals have their hearing sensitivity, you could look to one of these maps. In principle, we have calculated the maps at every 1/3 octavand frequency. So we can post-process the data and apply any filter that we would like, actually. Does that answer the question?
Yes, I think so. Thanks.
I think it will. Thanks, Chris. Go ahead.
Okay, yeah, so I have a question. Maybe for Jens. Jens gave the overview, and we saw especially with Lars with the deepest recording site, and Alain had a nice example for a very, very busy location in a very shallow site. Jens, do you think, you said we have a nice variety covered with all our 15 up to 18 locations. Do you think we cover all relevant habitat types actually in the North Sea? Your sound is still muted, so maybe that can be solved. Does that help? Sound coming from the left or from the right? Can we solve it over here? No, there is no sound coming from you, Jens. Okay, see whether that's maybe Stefan or Alain has an idea, because we know the variety of locations probably. No, we can still not hear you, Jens.
Could you just repeat your question, Hans?
Yeah, whether with all the hydrophone stations that we have in JOMOPANS, 15 up to 18. We heard Jens giving the overview. Whether we have actually now samples from all relevant habitat types, or whether we still miss anything between the 300-meter deep trench in Norway and the very shallow coastal system in Belgium.
I think that we have quite a nice variety of sites all around the North Sea. Of course, to be able to reply to such a question, we should put that information into a map of habitat as well, and then we could of course reply, because the way the station have been placed is a kind of a compromise on the lifetime expected for the station itself, the quality of the data that you may expect, the various underwater sound activity that you have on site, and also, of course, some key point for modeling as well. So I'm not sure that the question you raise here has been treated as a primary question for defining the location of all the station. So I don't know, maybe Niels has an idea about that, but maybe Jens now got some
Niels,
sound.
do you want to add something? No.
Yes, as Alain said, it is a compromise, the locations we choose, because it is also what can you do within your budget. And the most quiet area, as we saw on the maps, is the Dokkersbank in the middle of the North Sea, but it's also most far away and probably, so that is also an expensive station if you put it over there. So we are aware that it is not an optimal layout that we had, but we have tried to get as close as possible to that. Yes.
Okay, thank you very much. There are some more questions from the chat.
Yeah, there are. I think I will read out the questions and then you can answer in order, I think. There's a tricky question to Karen. Has there been experimental research where you make noise with different frequencies and see what is the impact on spawn? So you can think about your answer. I think this is a nice question for Christ. Are there any plans to study which mitigation efforts might be most effective? And the last question for Jens. Did you also detect impulsive noise, and how did you deal with that?
Okay, maybe Karen first.
Yeah, so in terms of frequency, I'm not aware of studies that directly compare the different frequencies as an effect on spawning behavior. But there have been studies comparing different types of sounds, such as intermittent and continuous noise. And of course, different sound levels.
And within the spawn size project, you're also looking into experimental exposure to spawning.
Yeah, and so we recently published a review where we actually looked at the different types of sounds and potential effects on reproduction, and there we found that continuous irregular noise may be most important for stress and masking, which could then affect spawning. And then in our spawn size project at the moment, we're actually looking at the effect of seismic sound on cod spawning behavior.
Yeah.
Thanks, Karen.
Okay, moving over to Chris then.
Yes.
Yeah.
Yeah, this is a difficult question, because the question that Annabelle posed is related to the effectiveness of mitigation measures. And actually, within JOMOPANS, we quantified the pressure on the environment, but we didn't look into the effects. So at the stage where we are now, we have the sound maps. We can demonstrate how much sound there is. We can look to the animal distribution map to see whether this happens at the same locations, but we are not yet there. It's the input for the next step. The next step is, what does it mean to the animals? And talking about mitigation, then you also need to know something about the effects, because otherwise you can't quantify the effectiveness of the mitigation. On the other hand, at the end of my presentation, I've referred to the study we did for the Belgian government, where we looked to something like a measure for the shipping noise to reduce by, for example, slow steaming. This is something what is done voluntarily in the Vancouver port area now to protect the southern resident killer whales there. And also on the North Sea, this might reduce the pressure on the environment, the sound pressure on the environment a little. What the effect is a more difficult question. It's one of the aspects that's being studied, is going to be studied in the Saturn project that's just started.
Cool, thank you, Chris.
Thanks, Chris.
Last question, Jens, about impulsive.
Jens or Alain. Yeah, maybe Jens or Alain.
Are you audible again, Jens? Still not.
Still not. Then maybe Alain can answer.
So you have a souffleur present in Alain.
And we have one more question. Hans?
Do you know that was the impulsive sound and how to treat that in the average pressure levels?
Yeah, whether you detected any impulsive sound during measurements.
That was related to my earlier question, and you said long distance pile driving is audible. Mm.
Yes, but you have to figure out what's the level of them, what's the occurrence of them, because it's only very limited time over the full year of measurement. So there is two possibilities. You can remove those measurements, or you can leave them telling, okay, it is also part of the ambient sound, because it's quite a long distance one. So that remains open question. When you will see on WP6, which is Ross work, the level of errors that you can expect between maps that are computed and real-time measurements, we are talking about monthly means also. So what is the effect of 1 hour of piling during one day, or twice a week, or 3 times a week over a full month? And since you are far away, the levels are a little bit higher than the normal background level, but not that strong. So
moderate impact, but
that's
also
I think the way we could reply today.
Yeah. So in processing, I think also no difficulty, as it's the impulsive nature at those distances is not so distinct anymore from the average background. There's one more question from Barry.
Yeah, it seems all the participants are able to hear Jens. So we don't hear you in the studio, Jens, but I think you can just answer, and the participants do hear you. The question was, it has been answered from the part of Rijkswaterstaat on the chat, but nice to see what the Germans think about this. Would it be possible to have a station in the Wadden Sea, and would you expect good results? So maybe wave at me if you have finished answering the question.
Areas which are not really wet sometimes at the day. So we had a lot of discussions in the in a project that also coastal stations are necessary. So maybe that's also an answer on the first question, that maybe near coastal stations are underrepresented in the selection of measurement. But as my colleagues explained, we tried to find a solution based on funding opportunities and feasibility of selection in the measurement sites.
Okay, thank you, Jens. That's the last part we did here as well in the studio. Maybe before we take the break, Stefan, one more question, kind of a follow-up on the impulsive sound. Is there anything that we should think of in terms of standardization when you think about very short-term nearby exposures with intermittent or impulsive sounds and the more long-term patterns? Is there any issue in that sense with standardization methods in the processing?
That's actually something that is going on at the moment in the standardization process. There are people looking at that, and for certain types of impulsive sound, pile driving, for example, there are standards describing how to measure it and how to analyze the data and so on. Not yet for things like air guns, but they're coming. In the next few years, you will, believe you will see activity there as well. And in terms of parameterizing what it is about the pulse, what it is about the sound that's causing the most problem for the animal, is it the peak pressure, is it the energy in the pulse, the SEL, or is it some other parameter, for example, then that's not really reached the stage where we can standardize, but certainly there's research going on into that at the moment with different groups around the world looking at periodicities, looking at kurtosis, things like this, and whether they are a more important parameter to actually measure and report when trying to determine what the influence is on the animal. And just going back to the question you asked me earlier, which I kind of dodged, which is about some of the definitions of some of the terms that are less familiar to the general population, things like the exceedance and dominance and so forth. Chris might want to chip in here, but it is true that those are less familiar than some of the other terms, although they're not completely novel. We're kind of borrowing ideas from other areas, but it is true we are trying to break a little bit of new ground here, and we're trying to represent the noise maps in ways that are meaningful rather than just having the absolute levels presented, which from which it's hard to tell anything meaningful about the impact on the sort of the ecosystem. So I didn't want to think I'd completely dodged that. I don't know if you wanted to add anything to that, Chris. The only thing I would finally say is that those terms are dealt with and defined, at least how we're using them in JOMOPANS, they're defined in quite a lot of detail in the modeling report. So we have expressed exactly how we use them. So Chris, you might want to say something in response to what I've said.
I'll try to keep it brief. On purpose, I didn't include it in my presentation because this opens a whole new field of explanation. I think it will come back in Jacob's presentation this afternoon. But in brief, the maps that Neil showed of excess level and dominance are all related to the ratio of or the amount of sound that the ships add to the natural background. And with the type of modeling that we've been doing, the natural background is limited to the wind noise modeling we had and the shipping noise. Well, we looked to the ratio of the two actually. How much does the ship noise exceed the wind noise, and for what percentage of the time of the month does that happen? So that's expressed in the dominance. That's a more percentage of the time that a certain threshold value is exceeded. The advantage of maps of modeling is that you can calculate these metrics for a large area.
Yeah, I think it's very nice.
Well,
But I think to see that as part of the standardization or the sound mapping, I think it has also a little bit of a danger, because it implies that we already know quite a bit about what is having the impact. What you also alluded to, Stefan, we don't know the typical details of the sound and what the impact is on deterrence or on masking. And therefore, by taking such a derivation of your raw data, I think has also a little bit of a risk, as long as you report maybe both or how you processed it, and then the stage at which we look into biological realism of impact. Of course, then we may want to go back to absolute levels or combine it with natural fluctuations in the wind noise and the additional excess level noise that we make. Okay, thank you very much. I think in view of the time, we need to take a break. I want to thank all speakers of this morning.